Hola, mi clase. Today is 9.2, properties of reflection. So I can reflect a figure given a description. Remember, that's us writing it out. And write an algebraic expression of the reflection. Okay, so remember that's that XY from translation. So a reflection is a transformation. I'm not sure what a transformation is. Let's delete that L. That flips a figure across a line. Okay, it's that flipping one. It does not change the size or shape of a figure, only its location. So it'll be the exact same thing, just flipped. It's like a mirror, right? That's what a reflection is. It's a mirror. So everything's the same, but it's been kind of flipped of where it is. Okay, it's like butterfly wings, right? When we fold, those butterfly wings land perfectly on top of each other, and they are perfect reflections of each other, right? But on the other side. So then we have what's called a line of reflection. It's a line a figure is flipped or reflected across. Okay? So it's like the center of the butterfly wings, right? So the figure shows triangle XYZ. We're going to graph the image of the triangle after a reflection across the y-axis. So we would consider the y-axis our line of reflection. Okay, so here's our line of reflection. This is where I'm reflecting it. All right, and so if we're going to take XYZ and move it across the y-axis and reflect it perfectly, what will happen is, if you notice, is that the x and the x prime will exactly be the same distance from the y-axis. So if you notice, x is 1, 2, 3 away from the x-axis. X prime is going to be 1, 2, 3, but on the other side. So they're going to be the exact same distance. Same with y. It's going to be y is 1 away, and y prime would be 1 away. So that's why you see these 1 and 1s. And then same, z prime is 5 away from the y-axis, or sorry, x-axis. So then it is 5 away from the x-axis. Z prime is 5 away on the other side. They have to be the exact same distance from my line of reflection. Okay, so we're going to regraph my shape the best we can. That's a really bad connection, so I'm going to fix that one. Getting as close as I can. I'm not doing a very good job. There we go. So if you'll notice, it is exactly still the same shape, but everything's just been flipped, right? It's like you took it and flipped it over. So where the X is further on, the bottom, now it's above, right? So it's completely flipped of where it is. All right. So we're going to talk about the algebraic expression, but I'm going to do it when we do it here in a second, just so that we understand how this works. So it's now telling us to reflect ABC over the y-axis. So now this is our line of reflection, okay? So now my y-axis is the line of reflection, so I want it to be the same distance from here. So if I go A is 1, 2 away, right? It's 2 away from the y-axis. A prime has to be 2 away on the other side. Okay, same idea, C prime, or C is 2 away, so C prime must be 2 away on the other side. Now I'm going to do B prime in another color just because it's kind of blended with C. So B is 1, 2, 3, 4, 5, 6 away. Okay, I'm going to draw a green line right here. And it's 6 away, which means I have to have B prime be 6 away. 1, 2, 3, 4, 5, 6. And there's B prime. All right, so I reconnect. And there's my triangle, A prime, B prime, C prime. Again, if you notice, A and C still line up, just like they did here. B and C line up here. They're the same distance away, 1, 2, 3, 1, 2, 3. So nothing about the shape changes. It's just where it is a little different, right? And they're completely opposites of each other, right? The B was furthest to the right, and now it is furthest to the left. It's complete opposite. Same thing here. Z was at the very, very bottom, so when we reflect it, it now ends up at the very, very top. All of its stuff changes. So same thing here. Y was at the very top, it's now at the very bottom, and that's because of that reflection. All right, so we're going to do this again, but this time we're going to reflect it, and then we're going to talk about the algebraic expression. Okay, so now we're going to do x-axis again. So that's this one. Oops, I don't know why I'm drawing it. Let me get my line tool out. Here we go. That's this one, right? This is the x-axis. Now you'll notice my figure, MPDZ, is overlapping this, and that's okay. It just means everything needs to go to its opposite. Everything. So if I look at, let's start with Z. Z is 1, 2, 3 here. It means it needs to be 1, 2, 3 here. And we get Z prime. And then a little bit different thing I'm going to do is I'm going to list my points. I'm going to go Z is at 1, 2, 3, 1, 2, 3. And Z prime is at 3, but now it's a -3. Okay, and this, I'm doing this so that we can look at the algebraic expression. So then D is 1, 2, 3, 4, so it's 1, 2, 3, 4. And there's D. Oh, that's not a D. D prime. Okay, and so again, D was at 1, 2, 3, 4, 5, 1, 2, 3, 4. Now D prime is at 5, but 1, 2, 3, 4 negative. All right, let's do P. P is actually 1 under, so that means P prime needs to be 1 up above. So it also needs to change. So it was at 1, 2, 3, 4, -1. And P prime is now at 4, 1. Now M is a little tricky. M is not above or below. It's directly on the x-axis. So we actually are going to leave this point, kind of almost like redraw it and label it M prime. It doesn't move. Okay, so M was at 3, 0, and M prime stays at 3, 0 because it's directly on the axis. So I then reconnect and remake this shape. And you can see everything has been flipped. P was at the bottom, now it's at the top. D was all the way at the top, now it's all the way at the bottom. All right, so now what we're going to do is write our algebraic expression. So I'm going to go xy. And if we look at our points, so you see that all the x's actually stay the same. 3, 3, 5, 5, 4, 4, 3, 3. Nothing changes. So we're just going to rewrite x, comma. Now something does change with my y's. I go 3 to -3, 4 to -4. I go to -1, 1, and then 0, 0. That one obviously doesn't change, but that's because of this. But if we notice, 3 to -3, well, that's the opposite. 4 to -4, that's the opposite. And -1 to 1 is still the opposite. Well, 0, 0, there is no opposites of them, so that's why it doesn't look like it changes. So how we write this is we go opposite of y. And what we have to know is this does not mean -y, it means opposite of y. Okay, so if it's positive, it now goes to negative. If it's negative, it has to go to positive, just like this one did on P. Okay, so that's our algebraic expression for when we reflect over the x-axis, very specifically, okay? The y's actually go to their opposites. All right, so this one's even a little more different because we actually have to graph our pre-image onto here, and then we're going to reflect it over the y-axis. So let's graph this. 2, 2, this is T. 2, 1, 2, 3, 4, 5, that's C. 1, 2, 3, 4, 5, 1, 2, 3, 4, there's Z. And then 1, 2, 3, 4, 5, 0, there's F. All right, let's carefully reconnect these. Now we're going to go over the y-axis. So here's our line of reflection. So just like we did on that other example, we just see how far apart they are and we get them to the other side. So C is 2, so C prime's got to be 2. T is 2, so T prime's got to be 2, but on the other side, right? Z was 5, 1, 2, 3, 4, 5, so 1, 2, 3, 4, 5, there's Z prime. Notice I'm not counting up or down. And then F, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, because I don't worry about that. I'm just moving it to the other side across this line. Then I'm going to reconnect. And see, my shape is the same. It's just been flipped. So if we go list T prime, it's now at -2, 2. And if I go to C prime, it's at -2, sorry, -2. Oops. -2, but still 5. If I look at Z prime, it's at -5, 4. And if I look at F prime, it is at -5, 0. So here's what I want you to do. I want you to tell me what is the algebraic rule for when we cross over the y-axis. Okay, remember what we said here and what changed. So I want you to see if you can finish what is the algebraic expression for reflecting over a y-axis. All right, we'll see how we do on that. All right, so the main thing to remember is reflection means or equals same distance from line of reflection. Okay, so that's the main thing we need to remember. So here's your independent practice. You are going to reflect this pentagon over the y-axis, okay? And then you're going to write the algebraic expression for that reflection. So here's your axis. I'm going to give it to you, but then you need to go write the algebraic expression. Hint, hint, it's going to be probably whatever you did here, okay? Alrighty. Oh, another hint, easiest way to do it is to list your points, A, B, C, D, and then list your prime points, A prime, B prime, C prime, and see what happened, okay? All right, until next time, adios.